Hi, I'm gonna run through the Leetcode medium problem present cells after n days. So first I'll go through the problem statement, explain the problem, and then I'll explain my approach, how to solve it. Then I'll go through the code I have written here and also how many test cases are passing with this. So the question is, there are 8 present cells in a row and each cell is either occupied or vacant. So that means it's an array of 8 integers of either 0 or 1. So 1 means occupied and 0 means vacant. So each day whether the cell is occupied or vacant changes according to the following rules. So if a cell has two adjacent neighbors that are both occupied or vacant, then the cell becomes occupied, otherwise it becomes vacant. So it basically says day 0, suppose this is the arrangement of cells. So day 1 should be based on the previous arrangement such that for every element, if both the adjacent cells are same, then it should be 1, and if both the adjacent cells are different, it should be 0. So that's basically the question is. So note that the prison is in a row. The first and the last cells in the row cannot have two adjacent neighbors. So the first doesn't have two neighbors and the last doesn't have two neighbors. So basically after the day 0, all the arrangements will have first and last as 0 here, because they cannot change, because one side is always it can be 0 or 1, but the other side we don't have any element, so it's going to be 0 always. So we describe the current state of the region in the following way: cells I equal to 1. If the ith cell is occupied, all cells I equal to 0. So this is basically the cells array. Given the initial state of the region, return the state of the region after n days, and n such changes described above. Yeah. So the input is the cells array and an integer n. So the maximum value of integer n is 10 to the power 9. So we have to return what will be the arrangement of cells after n days. So after 7 days it will be, I mean on the nth day we can say, so on day 7th it will be, this is the arrangement, so we have, this is the output. So if this is the input and n is supposed 10 to the power 9 here, so after on the nth day it will be, this is the arrangement of the cells. Yeah, so how to approach this problem? So if we think uh, brute force approach, so you can run through day 0, 1, 2, 3 up to n, and each day we can calculate what is the arrangement based on the previous day. So if we do this, what is going to be the complexity? So suppose I have day 0 arrangement like this, I want to calculate day 1. So for day 1, it's going to be running through the 8 elements, it's basically 6 elements of the array. So the computation is order of 1 for day 1, order of 1 for day 2, but when I'm running through a loop up to n days, so the complexity is going to be order of n. So but we can see the n maximum value is 10 to the power 9, so if we go with the linear complexity also, we are not going to achieve it. It's too high, so we have to think some other solution better than the linear approach. So now I'm going to explain the approach I followed, and it passed all the test cases for this problem. So if you can see, there are 8 elements here, and out of which after day 0 only the 6 elements will keep on changing. The first and last will remain same, and it can only be 0 and 1. So there can be a maximum 2 to the power 6 possible such patterns, which is 64. So uh, we know that after a certain number of iterations, the patterns are going to repeat, because there are maximum 64 patterns here. So at max, we can think like after 64 patterns, it is going to repeat, which is again a small number compared to the use n, which is 10 to the power 9. So using this, we are going to calculate the pattern on the nth day. So n can be 10 to the power 9 here, which is the maximum value. So keeping that in mind, let's go through the code. Okay, so I am using C++ here. So if you are using any other language, you can utilize the same concept and write your own code. Function we have to complete. It has two inputs, the cells array and the integer n. So my idea is to first convert this array into a string, so, because I want to use it as a key in the hash table. So why I'm doing this, I'm going to explain that. So that operation is happening here. I'm converting the elements of cells into a string first, and I have taken two maps here, m1 and m2. So the first map m1, you can see the key is a string and the value is the int, which is basically the pattern to day mapping, and m2 is day to pattern mapping. And the result is basically what we are going to return from this function, because the return type is vector of int. So we'll start with day 0, and we'll fill m1 and m2, like m1 and the pattern equal to 0, something like this, and m2 day equal to the pattern, like this. Then we'll run through a loop, and in each iteration we are going to calculate the next value of s. So the next value of s is basically, if day 0 is this, the next value will be this. So how we are going to calculate this? Let's look at the get next function. So get next function basically takes another string, which is having the length of 8, and will initialize it to 0 for all the characters, and result 0 equal to 0 and result 7 equal to 0. Basically this means the first and the last elements are always going to be 0, and we run through a loop starting from I equal to 1, I less than 7, so 1 to 6, and we calculate for each element of Si. We see if Si minus 1 equal to Si plus 1. So if we see here, this is I, Si minus 1 and Si plus 1 are same, so result I becomes 1. So for each element of Si, we calculate result I, and we finally return result from here. So what is the complexity of this operation? As we know, there are maximum 8 elements in the array, and we are just going through 6 elements, so it's going to be order of 1. Okay, now coming back to our original loop, we got the next s, we incremented day, we are in day 1 now, and here we check if this pattern is already existing in m1. That means the repetition started now. If that is true, we return from here. If there is no repetition, we just add it to the map, both the maps, m1 is equal to day, m2 day equal to s, and we continue the loop. But before continuing the loop, there is a check here, which means if our n is very small, and before getting the repeated pattern itself, we have completed n iterations. So that means we can return the result from here itself without going further. So this get result basically converts the string back to the vector int, and we return the result from here. In case we don't return from here, and we find a repeated pattern and we break out of the loop, we come to line number 57. So in line number 57, we find what is the previous day for which we are getting a repeated pattern here. So this is the iterator for that. So suppose for day 1 and day 15 we are getting a repetition, so this iterator will point to day 1. So that is D1, which is iterator second. Why you are taking iterator second? Because this is M1 second is the day number, and D2 is the current day. We have already incremented day here. Uh, then we see what is the repetition. So what is the interval basically? I should have named it interval. So it's D2 minus D1. So after this many days we get a repetition, and it's gonna continue up to n, because once we come to the same number we are going to follow the same steps, and again it's going in a loop. So then we see what is the value of n. Like suppose the value of n is 100, and we see every 30 days it's gonna repeat. So 100% 30 is going to be 10, right? So we need to return the pattern which is 10 days after D1. So that value is already present in our M2 map. So M2 is basically the mapping between the day and pattern, and that is our result. So finally we convert it into the integer array and return from here. So if we look at it carefully, what is going to be the complexity of this approach? So the time complexity is going to be order of 1, because we know the maximum value after which the patterns are going to be repeated is 64. So we are not going to do more than 64 operations, and once we get the repeated pattern, we break out of this loop, and then we do some calculations and get the value of s on the nth day. So we are, these all are basically order of 1 operations, and this is also order of 1. So the total complexity of this approach is going to be order of 1. Yeah. So if you feel there is any better approach, feel free to comment. I'll definitely go through the solutions and your comments, and I'll explore if I can make it much better. So let me run this program and show you the output. Yeah, so it got accepted and faster than 94.17% of the solutions. So that's it. Thanks for watching. See you next time.